Please copy down the definition for bond enthalpy. When we consider the energies associated with various types of bonds and see how the bonding concept is useful in dealing with energies of chemical reactions, we can look at this example here, where we have several organic structures that are breaking down into its components. So we're talking about taking an average here and dividing by 4 and go through this process here. But how does the CH bond differ for each of these cases? Meaning I have carbon attached to 4 hydrogens, a carbon attached to 3, a carbon attached to 2, and a carbon attached to 1 hydrogen. And how is that different? Okay, so how does the CH bond differ for each of these cases above? And we just use a simple average for that. So let me explain to you how we're going to calculate how we get to these values here next. We're going to skip this section to this year, as I'm not sure where everybody is, nor do I, with the end of the semester approaching us, I'm not going to take the time to reteach this or review this. Instead, I will just give you the structures as we go through this. So we're going to skip 26 in our notes, so skip over to 27. Okay, for bonds to be broken, energy must be added to the system in an endothermic reaction. Okay, so in order for bonds have to be broken, obviously, in order for a reaction to take place. And so that bonds can be formed on the other side to form products. So the formation of the bonds must release energy as an exothermic reaction. So the new formula that we're going to use, or the new algebraic formula, is the change in enthalpy, is going to be the sum of the broken bonds minus the sum of the formed bonds. This is the first time reactants will be first. Reactants are first, products are last. So don't get those two confused. In the other parts of the unit, we've always done last as first and first as last. In this part, when we're talking about bonds being broken and bonds being formed, you're going to put reactants first and products last. Okay, so a lot of this is going to be done for you going forward in your notes, but I am going to go through this as an example here. So we have H2 and gaseous H2 reacting with gaseous F2. So normally you would be expected to produce these structures yourself, these what we call molecular structures. But I'm going to give those to you in all of your examples here, so you will need to use these notes to be able to do your homework. So this is what you would have come up with had you built the structures yourself. Okay, and now you're going to think about the types of bonds you have on each side. So remember that we're going to take reactants minus products. This is the first time that the left is first. So we're going to look up, we see that we have, what kind of bonds do we have? We have HH bonds, and we have one of them. We have FF bonds, fluorine-fluorine bonds, and we have one of them. On the other side, we have HF bonds, single bonds, and there are 2 of them. So now we're going to look at a table to get a value, bond energies table, and I will show you where that is. Give me just a moment, I'll go do that. Okay, you're going to be able to find that bond energies table in several places. First of all, you can go to the thermochemistry folder. It'll be in the unit PDFs, right here, bond energy data table. More closely related to what we're working on. I also put it in both of these folders for today and for Thursday. Okay, so we're going to go open that up and we're going to use that table. So we're going to use this table in this way. We're going to look for HH bonds, so you're going to just look through all the different lists of the bonds. Notice that in some cases there are double bonds, that's 2 sticks, right? In some cases they're triple bonds, 3 sticks. So be sure you're picking the correct type of bond. Doesn't matter what order the bond's in, meaning I could have C then H or H then C, it doesn't matter. Again, I could have HCl or a ClH. Doesn't matter what order the elements are written, as long as it's those 2 elements with a single, double, or triple bond, that's what you pick. So we're going to pick 432. So we're going to say that's going to be 1 times 432. That's a 432. And then going back, we're looking for FF bonds. So I'm looking through the list and notice that these are kind of by group numbers. So that would be your group numbers at the top of your periodic table. Okay, so I'm looking for group 17, fluorine, which would be 155. 155. So that's going to be 1 times 155. And then over here, we're going to say 2 because there's 2 of them, because this tells us there's 2 of whatever's right after it. So 2 HF bonds. So I'm going to look for HF bonds. It's going to be in the H's here. HF bonds is 565 times 565. Oops. And now we're going to calculate these values here. So we're going to get the sum of this and the sum of this. Obviously, this is going to be 432, and this is going to be 155, and then 565 times 2 is 1130 over here. So this side's going to be 1130, and then this side is going to be 432 plus 155, which is 587. And then from the reaction formula, or the algebraic formula that we have right here, we're going to take the sum of the bonds broken, that's your reactants, minus the sum of the bonds formed, that's your products. So we're going to take 587 minus 1130 to get our value here. And we get negative 543 kilojoules, as would be the unit, based on the data table. Do not hesitate to reach out for clarity if needed. Let's look at number 28, example 28. Okay, so we have lots of things going on here, but I think it's helpful, as I did, and I didn't mention, but as I did on the last problem, is to kind of split this right down the arrow. So this structure here, you will not have to know this, but this, I will give it to you. You may know how to do this. You may not remember. I'm not going to take the time to review it with you today. I will instead just give you the structure. So that's what that looks like. And then we have Cl to Cl. Again, these are things that you could build. You were taught how to do it in first year chemistry. But instead of spending the time to review that, I'm just going to go ahead and give that to you. So in this structure here, we have four CH bonds. So from this piece, we're going to say we have CH bonds, and there are 4 of them. And then from this structure here, we have Cl bonds, Cl to Cl bonds, but this 2 in front says that we have 2, because a 2 here would say it would be that I have 2 of these, and these are come as 1 and 1. And then the fluorine-fluorine bonds, we also have a 2 in front here, right up here. So the fluorine-fluorine bond is going to be 2. We're going to look those numbers up in just a moment. We're going to come over to this side, and again, this structure, these structures will be drawn for you. So just as a reminder, and I don't expect you to be able to do these structural formulas in this year, I'm going to give them to you like I've instructed. So here we have CF bonds from that piece, so there are 2 of them. And this piece also has CCl bonds, and there are 2 of them based on the drawing. Again, then you would know H to F. Again, you don't have to draw these things. I will give them to you. This 2 in front says I have an HF bond, and there are 2 of them. And then HCl bonds would look like this, and that only has HCl bonds in it. No necessarily reason to repeat this. I'm just going through this as instructional piece here, and there are 2. And again, these 2s here and here and here and here because of the number in front. If there was a 6 out in front of this, then I'd have to say 6 times everything after it, so it'd be 6 times 4. So however many are out in front is what you multiply through. Okay, so now we're going to start looking up these numbers. We're going to look up CH. And that's a carbon-hydrogen single bond. Carbon-hydrogen single bond. So we're looking in the carbon-hydrogen single bond right there, 411. Sorry about that, 411. So that's going to be 4 times 411. Chlorine-chlorine bonds. We're looking for chlorine-chlorine bonds. Right here, 240. So that's going to be value 240. Fluorine bonds, 155. It's going to be 2 times 155. This was 240. Okay, and that gets that piece done. We'll do the math in a minute. Carbon-fluorine bonds. So right here, 485. 485. And then carbon-chlorine bonds, 327. So you're just looking these up. Key is to figure out how many there are. 327. Hydrogen-fluorine bonds, which we don't have on the other side. If we would have had it on the left side, sometimes that's the case. 565. And then hydrogen-chlorine bonds, hydrogen-chlorine bonds right here, 428. Okay, so now we're going to do the math. We're going to multiply all these up and get the new numbers. So we're going to take 4 times 411, that's 1644. So 1644. And then 240 times 2, which is 480. And 155 times 2, which is 310. And this is overkill, but I'm going to show you the math here. You don't have to show this part. I do expect to see that stuff up there for credit, so be sure that you're doing it that way. Over here, we got 485 times 2, which is 970. I didn't leave myself enough room, so I'm going to go here. 970. And 327 times 2 is 654. And then 565 times 2 is 1130. This is 1130. And 428 times 2 equals 856. So I do expect all the parts up top to be done, all this stuff to be done. And then this could be skipped, and you can just do it on your calculator if you wish. Although it may help you keep yourself organized, so it might be worth the moment it takes to write it down. All I'm doing is taking the pieces up above, and I'm going to sum. Okay, so now we're going to take the sum of these values. So 1644 plus 480 plus 310 gets me 2434. Minus, because the way we set it up, 970 plus 654 plus 1130 plus 856 is 3610. And so when we take 2434 minus 3610, we get negative, the final answer to be negative 1176 kilojoules. Okay, you will need these next slides to do your homework. Okay, so this is, the blue is the part that's given, and then the black below is it drawn out, so you don't have to draw the structures yourself. There you go. Remember that's 2 of everything in here. So whatever count you get here, that's twice as many of whatever you get. So right now we have 1, 2, 3 nitrogen-hydrogen bonds, but there's 2 of that structure. So that means 6 nitrogen-hydrogen bonds. There's 65. 66. Again, I have the pieces underneath here drawn out for you, and these are already done for you. This is a carbon-oxygen double bond. This is a carbon-oxygen triple bond. Remember, that's going to be 3 of those. So that's 3 oxygen double bond oxygen. This is 2 carbon oxygen double bonds. So there's 2 carbon double oxygen bonds. And this 2 out in front says then there's 4, because there's 2 carbon double bond oxygens per unit, and there's 2 of the units. And then there's 3 here, so this would be an oxygen-hydrogen bond. There's 2 oxygen single bonded hydrogen bonds per water structure, so that's 2 times 3, so 6. Follow that similar pattern. There's a 5 out in front of here, so 5 times all the pieces you see here, 4 times these. I do need to give this piece to you. I just realized I didn't give that to you. So this piece here would be C H like this way, this piece here would be attached to that nitrogen. So this whole piece here is that. That's a single bond. And I'm just trying to draw this piece right here down here for you. Reach out if you have any questions or concerns. And here are the answers. Reach out if you have any questions or concerns. Have a great evening.